Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on course schedule. Let me directly explain it in the question. So let's jump to the question, understand it and start solving. This will be a problem on graph, okay? So last time we have solved the evaluate reverse Polish notation. You can find it in the list. Let's start with course schedule. Okay, so there are a total, let's go through the problem statement. There are a total of numCourses. You have to take labeled from 0 to courses minus 1. You are given an array prerequisites where prerequisites AI, BI indicates that you must take course BI first if you want to take course AI. Okay. For example, the pair 0, 1 indicates that to take course 0, you have to first take course 1. Return true if you can finish all courses, otherwise return false. Okay, so it is little tricky to understand this way. Let's understand it from the example. So we have to finish 2 courses. Prerequisite is given that in order to finish course 1, we need to finish course 0. Okay, so first we finish course 0, then we finish course 1. That means it is possible. There are total of 2 courses to take. To take course 1, you should finish course 0, so it is possible. In the other one, we have to finish 2 courses. Prerequisite is 1001, which says to finish course 1, we have to finish course 0. But to finish course 0, we have to finish course 1. So it's like a deadlock, right? So it is not possible. To take course 1, you should have finished course 0, and to take course 0, you should have finished course 1. So it is impossible to do that, right? If you understand this, you can see. So first, before I go on explain this problem and the solution, just take a minute and think how you would approach this problem. Okay, let's start. So if you see, you can see 1 has a prerequisite 0, so you can attach 1 to 0. Similarly, you can attach 0 to 1. If you look at it from the bigger perspective, it's a graph, right? We can actually solve it using a graph, and we can create the directions. So 1 is attached to 0, 0 is attached to 1. You can clearly see a cycle. And if a cycle exists in the graph, that means it is not possible, we return false. If cycle does not exist in the graph, then we return true. So we will solve it using graph. Okay. Now how will we solve it? First is we need to form graph out of this prerequisite and numCourses, right? So we'll create a graph in form of adjacency list, right? That's how we can represent a graph. So we need to create a graph out of this. Create graph, or we can say build graph. Second is, now we have built a graph, we will just go through the graph. So we'll use either BFS or the DFS. Let's go with DFS. We'll do a DFS search through the graph and check if a cycle exists in the graph or not, right? So we'll check if cycle exists, because if 1 is attached to 0 and 1 is pointing to 0, 0 is pointing to 1, that means a cycle exists. Cycle exists, that means it is impossible, because now there will be a loop. Before completing course 1, you have to finish course 2. Before completing course 2, you have to finish course 3. Before completing course 3, you have to finish course 1. So you see, we can see a cycle. So easiest approach would be, first is to build a graph, then do a search and check if a cycle exists in the graph or not, right? Okay, so let's jump into the solution. Please pay close attention, understand it. Understanding graph is little trickier, but since this is already an advanced journey in Grind 75, I'm sure you will be able to cope up. Or please go through the understanding of graph first and then come to this problem statement. Okay, let's start. So first we'll build the graph. So now before we build the graph, right, let's be sure that there are only few things that we have to do. Okay, First is that we have to build the graph, check the cycle. These are the only two things that we need. Apart from that, what do we need is we are going to perform DFS. We don't need separately DFS. DFS is something that we are going to perform to check the cycle and to traverse through the nodes. Okay, so we'll build the adjacency list. Adjacency list would be to build the graph. Adjacency, right? Adjacency list representing or representation. Okay, representation of the graph, to represent the graph. Okay, so how do we represent adjacency list, right? We'll create a map of integer list of integer. So each number is associated to a list of number, that's the adjacency list, and we'll create in a map. Graph is equal to build graph. Okay, so we need a method, right? We need a method to build the graph. So we'll call it helper method. Helper method to build the adjacency list representation of the graph. Okay, right? Now in order to build graph, what all do we need? First is we will return it in form of graph, so that then we can perform the search operation and check if the cycle exists or not, right? So we'll say private map integer, we need the same format, private map integer list integer. Okay, build graph. Now what all do we need to build this graph? First is we have to supply the courses, that is total number of courses that we have to finish, and the prerequisites. We'll use these two things, right? So we can say int numCourses and int prerequisites. Let me expand it so that it comes in one line. Okay, so we can pass the same things here. We'll copy and paste. Okay, now let's imagine we'll write this helper method. Okay, let's imagine that now we have a graph. Okay, now graph has been built, because the only job of this build graph method is to build the graph. Okay, now the graph has been built. What do we need to do next? So we'll create a while performing the search for DFS, we need to keep the track of all the nodes that we have visited. So we'll create an array for that, to keep track of the visited node. Okay, or let's say visited nodes during DFS. Okay, so we'll say boolean, we'll call it visited. What should be the size of it? Now think of the size would be same as the total number of courses. Num courses. Num courses, right? Now we have an array also. Now let's perform the DFS. Okay, perform DFS. Why are we performing the DFS? To check the cycle, right? So for int course is equal to 0, course is less than num courses, that is the total number of courses, course plus plus. You can use I as also, it's just more relevant, right? If not visited, if that course has already not been visited. Okay, if it has not been visited, we need to check cycle for this current node. So course here is representing this one node. Okay, out of the two subjects, one subject, one course. Okay. So we want to check a cycle or not. Okay, let's create a method to check the cycle also. We'll call it helper method to not to build but to check for a cycle in the graph using DFS. Okay, so we'll say private cycle has to be written in true or false, boolean has cycle. Now what do we need to pass it here? Okay, let's understand what all do we need to pass it to has cycle, because this is where we'll be performing a DFS search, right? So this is where we need all the values of all the nodes that we have visited, plus our original graph, and plus our current course for which we are checking, right? So we can say we would need at least our map, so we'll directly take it from here. We need our map, right? We'll call it graph as here, right? We need this graph to be passed to this method. Secondly, we need to pass this visited, so we'll take our visited array. What else do we need? Now since we are going to perform a recursion to check the cycle, we need to pass another array to keep track of it. Okay, okay, I'll come to this part, but we need another recursion stack, so we can actually call it boolean only, boolean and recursion stack. This stack will be used to mark the nodes visited for this current stack. So let's say there is a big graph 0 1 2 3 4, all are connected cyclically. So for node 1, and when we are checking inside 1 for 2, inside 2 for 3, using the DFS approach, on that current recursion stack will mark 1 as part of the cycle, right? But if in the end it is not solved, we'll mark it false again. So we need a separate visited array for the current recursion stack also. So this job recursion stack would be same as the visited, it's just be valid for that one recursion. And of course the course, let me expand it further. Okay, the methods have gone too big. Okay, we need all these things. So let's pass them here. So we are saying int if visited, if course has not been visited and has cycle. To perform has cycle, we need to pass our graph, we need to pass visited, and we need a boolean for recursion stack. So we'll say new boolean of length, our course length, numCourses. Okay, and then our current course. So if that course has already not been visited and has a cycle, so it was not visited earlier and now it has a cycle, that would mean cycle is found, right? Cycle is found means return false, so we'll say return false, it is not possible, right? Otherwise, when all of this is over, in the end we can say no cycle found, return true or return true, right? That's it. This is the whole solution. Okay, remember the solution is only this. First is we build a graph, so we change this nums and the prerequisite in form of graph, and then we only find if for each course that has not been visited as of now, if there exists a cycle. If the cycle exists, that is false. If the cycle does not exist, that is true, right? Now these are just the helper methods, so we can finish them quickly. Now how will we build a graph? We have the courses, we have the prerequisites, right? We need same thing to return map integer list integer, we call it graph is equal to new hash map, oops, right? And we'll say for int prerequisite from prerequisite, okay? And then we'll say now these prerequisites contain these things, right? Or you can see this, it's an array of array, right? So two-dimensional array. So one prerequisite would be one array, right? Now it will have only two elements, one element and second element. So these are going to be the courses, right? So we can say int course is equal to prerequisite of 0, and int, now it says for 0 1 indicates that to take course 0 we have to take course 1. So 1 is a course which is required before 0. So we'll say int prerequisite course is equal to prerequisite of 1, right? I hope there comes out to be no spelling mistake in these, okay? So we'll pass through the prerequisites, we take out them as the course and the prerequisite course. So like 0 is course, 1 is the prerequisite course to be completed before taking the course 0 for each one of them. And then we'll add it to the list of each course, so that now we will know that in order to complete each course we need to complete the other set of courses, and that's why we need adjacency list. This is like adjacency list, integer which is attached to a list of integer, okay? So once we know these value, we can say oops, yeah, so we can say add the prerequisite course to the adjacency list, adjacency list, which is graph, right? The course, okay? So we can say graph. Now graph is actually a map, right? So we'll use the direct method compute if absent, okay? Compute if let me write the method and then explain it to you. It's a beautiful implementation of lambda expressions as well. I'll say k, I'll say new array list, okay? And then okay, let's understand it as of now. So compute if absent, what it does is for course, key course, we are finding its adjacency list, we are finding its list of integer. If it exists, then okay. If it does not exist, so in case it is absent, we'll create a new blank array list, right? So that when we are entering the course for the first time, its list will not exist in the map, so we'll create a new array list. When we come here next time, we'll fetch the list which already exists. So compute if absent, okay? And then we'll add the prerequisite course to it. So add, that's how you add in the map, prerequisite course, okay? So we'll add prerequisite course as part of the list for course. So we'll search with the course will be the key, value would be a list of prerequisites, and we'll keep adding the prerequisite set of courses to the course, okay? And in the end the graph would be formed, and we can simply say return graph, because we are going to perform this for all the prerequisites array, right? So this is just a helper method in order to build an array, build a graph. Please go through these statements again and understand it, okay? Now hash cycle method, let's come to the hash cycle method. So first is oops, when we want to calculate hash cycle, okay, first we'll mark visited as true for this current course is equal to true, right? Similarly, recursion stack is also a visited boolean array for the current text stack, current recursion stack, sorry. So we can say recursion stack on course will also be marked as true, because now we have visited this. Now we are going to visit the neighbors. So we'll visit neighbors. So we'll say if graph dot contains key will pass, so key is course, will pass course. So if the graph already holds this course, we need to check for it, right? So one by one we'll check for all the courses. For int neigh pur, we'll call neighbor would be graph dot get course, right? Because here we have added all the courses at the in the array list for one current course. So all the neighbors for the current course can be found out by graph dot get course, right? Now once we have that, okay, we will check if we have already visited this neighbor or not. So if not visited for neighbor, we'll check if. Now we are going to call recursively, since we are performing DFS, right? As I mentioned, 1 is attached to 2, 2 is attached to 3, 3 is attached to 4. For 1 we are checking 2, inside 2 the neighbor is 3, for 3 we are checking for 4. So for this is DFS rather than BFS, okay? So now for each neighbor we'll perform the whole operation again. We'll check has cycle. We are calling this method again. We'll call has cycle for the neighbor, right? So we'll pass first attribute is graph, next is array visited, next is recursion stack, and the last one is our course, which is neighbor in this case, right? If it has cycle, so if it has cycle, we can simply say return true, right? Now if not visited neighbor was true, so if this neighbor was not visited, we'll check for the cycle. If the cycle exists, we'll return true, otherwise nothing. But in the else part, well, let's check. In the else, if this neighbor already exists in a recursion stack, that means in this current recursion stack call, this neighbor has already been visited. That is also like we have already visited this, right? So we can say if the neighbor is already in the recursion stack, that means there exists a cycle, right? So cycle is found. So we can simply say return true, cycle exists. Now if it comes out of this complete loop, first for the backtrack, let's name it backtrack, we'll mark recursion stack of this course is equal to false, and then we can return course, right? Sorry, why return course? So we have to return boolean. Oops, false. So if cycle is found, true. If the element is already found in the recursion stack, that is it was already found in the neighbor of the neighbor, will return true, that the cycle exists. Otherwise for this current recursion stack, will mark the course as false again and will return false for that recursion stack. Or if when it comes out of the complete recursion, will mark false, that means cycle does not exist. So let's go again. This is the solution. We make a graph, we use the build graph method, we go through each of the neighbors in the graph, we check that if a cycle exists, we return false, that it is not possible, okay? If a cycle is not found, we return true. The other two methods, build graph and has cycle, are just helper methods, okay? Let's run it. Now I could have taken a much faster algorithm. Oops, there are a lot of errors. Line 4. What is the error? numCourses. in numCourses. We are correct here. What's wrong? What are we missing? We are missing something. numCourses. Is the spelling correct? Let's just run it. It's showing the same. Okay. It is showing on the complete one. Error dot class expected. Expected. Okay, let's understand this map. Integer, list, integer, graph, build graph. Oh, why would I say int? numCourse is already present, right? Oops, silly mistake. Let's see. Okay, yeah, as I was saying, I could have taken a much faster approach for this solution, but since this was a really complicated solution, I wanted to take a faster approach, a more easier approach to understand. You can go with few of the faster approaches as well to solve this problem statement, but I would suggest that you first go through this solution, since this is very easy to understand and very easy to implement, and then you can go for faster approaches. Okay, so yes, that's all from today's video, everyone. If you have anything, please let me know in the comment section. That's all. Please like, share and subscribe. Thank you.